Hello, Itmar.
Hello, hello. How are you, sir?
Good, good, and you?
Uh, Thank you. Good. It's a great honor for me to talk to you.
Sure. I cannot actually see you. I see myself in your screen.
Um,
Um,
yeah, okay. Um, Maybe now you
Here we
see.
are. Now I see you.
Okay, can do like this, maybe. Yeah.
Sure.
Um, Hi, sir. How are you?
Good, good. And how are you?
I'm fine, thank you. Really appreciate you agreeing to talk to me. Well, I have.
Sure.
Okay. Can I ask you some questions, please?
Yes, go right ahead. Go right ahead.
Okay, thanks. In 1989 and 1993, while dopamine was widely conceptualized as pleasure molecule, you together with Trey Robinson proposed that the brain mechanisms involved in wanting are dissociable from those involved in liking, and that the mesolimbic dopamine system mediate wanting, or in particular the psychological process called incentive salience, but not liking for the same reward. And a reward can be passed to specific psychological components like learning or liking and motivation. And you show that the motivational and liking aspects of reward are dissociable. And many researchers today still posit dopamine to act as a teaching signal, like the conceptual, like the computational models, like reward prediction errors in the temporal difference reinforcement learning, or the habit system. They are all like learning hypothesis of dopamine. Yeah, whether
Yeah.
it's a habits or reward prediction error. Now, I want to ask you about that. So, um, some even separate, make distinction between tonic and phasic dopamine. So they say, okay, yeah, for motivation is like the tonic for performance, and while phasic is a teaching signal. So this is a long debate. It's like a war, the dopamine wars. But what is dopamine and what it does? Yeah.
Well, you're right. These are, in a sense, wars. They continue to go on. The learning hypothesis is very attractive to some neuroscientists, partly because the dopamine firing that Wolfram Schultz showed conforms sometimes to the prediction error equation, the temporal difference equation. Um, that's very attractive. On the other hand, I don't think there's really any kind of learning that becomes impossible when dopamine is removed. Dopamine isn't necessary for any learning. Learning can happen even in a dopamine-free brain in a number of experiments. So I think the system does learn, but it's learned an output. The learning is going on before dopamine. Dopamine is an expression of the learning, and it's because rewards are mostly learned about. So the incentive salience gets assigned to a learned target often, and that's I think really what the dopamine neurons are doing.
So if I understood you correctly, the dopamine it's like spikes in motivations, let's say,
Yes, I think that's fair. I thought that's a good description.
in response to a cue, a reward related cue or something.
Yes.
Okay. And now I must talk about addictions because of this incentive sensitization theory of addiction. And we know that one researcher, very known one, I think from Mexico originally, she claimed uh, about the opponent processes theory of addiction, like because of the bombardment of the dopamine neurons while the drug abusers take drugs. So there will be some homeostatic alterations, okay, because of that bombardment. But let's say the drug addict, withdrawal from the drug, and now he's free from the drug. So let's say it's a prolonged withdrawal. What will happen then? Maybe these homeostatic modification maybe are long gone, but still we can see that his cravings, especially in response to cues of drug-related cues, will be intense. So not only the sensitization remains intact, but it's also increased during the prolonged withdrawal. So how can such theories like the opponent processes can explain like incubation of drug cravings?
Right. Well, I think the opponent process theory doesn't explain the incubation of drug craving. The opponent process theory would predict that craving would gradually diminish in drug abstinence as the B process, gradually weakens. The opponent process theory promoted by George Koob, especially, but also Nora Volkow, whom you mentioned, I think. There's many things that are good about that theory. I mean, it is, everyone agrees, I agree, that withdrawal, people often take drugs to avoid withdrawal or to escape withdrawal and other distress. So to the extent that distress exists, people might take drugs to reduce that distress, and that fits the opponent process. But you're right to say that drug addiction and craving and relapse often persists even after drug withdrawal has gone away, and even in situations where a person is not distressed by other things, and yet the craving can happen, especially encountering drug cues can trigger the craving, and especially the intensity of craving can change, can from time to time, from cue to cue, it can vary in intensity depending on the state of the person at the moment. Emotional stress or emotional excitement will exaggerate the craving, will amplify the incentive salience. Taking a hit of the drug will amplify the incentive salience to promote a binge of relapse. So all of these things can persist, and the opponent process theory doesn't address that. That's what the incentive sensitization theory does address, maybe uniquely.
Yeah, I forgot the term that you used, like let's say I am deprived of salt and I want salty food. So you said hedonic and incentive with a term that I don't remember the term exactly. That we change the state. We now want
right. Alliesthesia may be the term you're thinking of. Alliesthesia.
Yeah, exactly.
Yeah. Yes, so hedonic alliesthesia happens. That's been known for a long time. And incentive alliesthesia also happens, usually together, but sometimes the incentive alliesthesia can happen first or by itself. And yes.
Yeah, you showed that when you deprived, I think it was with angiotensin 2 and renin system to deprive them from they feel like they want salt, and I think they never tasted the salt as nice. Yeah, they always remember it as aversive, as something like Dead Sea salt. They don't want it, and it's aversive. But even though immediately, before ever tasting it as nice, they were very attracted to the what was it was the lever. I think it was a lever as a cue for the squirt of this salt. Yeah, so, yeah.
Yes, you're absolutely right. That's right.
Pardon, I couldn't hear you.
Yes, you are absolutely right. You are right.
Yeah, so here I think it's really against any learning theories, because he learned about the salt, that it is the aversive. So yeah, if I have a predictive value like of the CS, yeah, because I learned it, I should run away.
Absolutely right. You're 100% right.
Now, some Parkinson patients, they take like agonist drugs, dopamine agonist. I think it's for the D2 receptors or something, I think. And some of them, not all, tend to present with impulsive control disorder, like with compulsive addictions for sex and gambling. Now, these people, I don't what are the implication of this phenomenon for theories like, let's say, like from England, like Trevor Robbins and Barry Everett, for example, like the habit. I think they see addiction as habits now, and they emphasize the role of executive function deficits, especially, let's say, in the right inferior frontal gyrus and orbitofrontal cortex, like they have the impairments and deficit of impulse control, inhibitory control. Now, I don't think, maybe I don't know, that these Parkinson patients, when they stop using the drugs, they are not addicted to sex and gambling anymore. So I don't think they have any kind of executive function impairments, and it's essentially only the dopamine cause it, not any kind of impairment. So what can they say, for example, about it? About
Well,
this?
that's a very good question, and we really should ask Trevor Robbins and Barry Everett. But I think they would say that the behavioral addictions of the Parkinson's patients taking these drugs are habits. Now, in a sense, they have to be right when they say it's a habit, because people do these things again and again. So descriptively, habit fits when we're pursuing things again and again. But the question is, why are they doing it? What's the mechanism that makes them do it again and again? And that's where I think you're right. Trevor Robbins would have some trouble. They say different things at different times in explanation. Sometimes they say it's like an automatic habit that happens when you're not paying attention. So you're thinking of something else and you find yourself doing this habit again. That can happen in real life. Of course, we have habits that come like that, but that doesn't really seem to fit an addiction, because addictive habits don't happen when a person's thinking of something else. They usually happen when the person's thinking of that addiction thing, that target. They want that. Other times, Trevor Robbins has suggested it's something like Tourette's syndrome, an involuntary movement where the basal ganglia of the striatum is making this movement even if a person doesn't want to. That happens in Tourette's and some other neurological syndromes. But again, I don't think that's a good description of addiction. Addicts don't say my hand is making me take the drug or my hand is making me gamble. They themselves, the person, is gambling. So it's not really against their will. At other times, Trevor Robbins' group has suggested, well, maybe the habit of gambling or taking the drug or binge eating, maybe it's that habit that has to be performed or else the person feels distress. So it's a little bit like the opponent process theory, where if a person doesn't take the drug, they feel withdrawal distress. But what Barry Everett and Trevor Robbins have suggested is that if you don't perform the habit, if you don't perform the action, you feel distress, and you perform the action to make that distress go away. So they say different things at different times, and some of them are a little plausible. Others are just not plausible at all. I think the habit theory is declining in addiction neuroscience. I think people are becoming more skeptical of it as an explanation. It's a good description. People take drugs again and again, or they gamble again and again, but it's not an explanation by itself. We need something else, like motivation.
Yeah, so, exactly. Maybe it's the habits is driven by very intense and let's say compulsive motivations. Maybe, yeah. So they describe it like OCD, for example. Like, if I don't do the habit, I will be distressed. It's like something with obsessive compulsive disorder, let's say.
Yes, I think so. Exactly so.
Okay, and in another study, you showed that very similar to the one I already mentioned about the salty Dead Sea solution, that by central amygdala activation, the dopamine mesolimbic system was recruited and generated a strong compulsions for one reward over the other, for let's say for the cocaine over the cocaine and the sugar over the sugar, or the cocaine over the sugar and the sugar over the cocaine, and even generated addiction, or let's say for a shocking road. So like you produce a wanting for what hurts, I suppose. So um, this, I think, clearly demonstrate that you can actually generate addictions. So no, I don't. This mouse, we cannot say a dysfunction in, I don't know, in his orbitofrontal cortex or prelimbic um, um, prelimbic cortex or infralimbic, and not basically the recruitment of the dopamine system by the amygdala. That's what I understand.
Yes, I think you've got it exactly right. It's generating an addictive incentive salience motivation, and there's not a cognitive dysfunction. It's not a habit because we can create it, in a single day, in a single half hour. It's theirs. It's wanting without liking and without habits or cognitive dysfunction.
So if we mention the amygdala, what the role of the amygdala in reward, in fear? Because people.
Well, I think yes, I think the amygdala it is involved in fear and it is involved in reward. It isn't that the addiction is coming from the amygdala necessarily, even when we stimulate the amygdala. What the amygdala is doing, I think, is sort of it's perception, learning, motivation interface. The amygdala recognizes what to be afraid of in the world or what to want in the world. But the amygdala is triggering activation of the whole dopamine system. When we look at the brains of the rats, after they've been attracted to the shock rod, right after they've been attracted to the shock rod, we don't just see amygdala activation. We do see that, but we see dopamine, we see ventral tegmentum activation, nucleus accumbens activation. It's basically the amygdala is recruiting the entire mesolimbic system to make the shock rod wanted and to pin the wanting. But what the amygdala is doing is helping to focus the wanting on just the shock rod. That's why we have the stimulation in the amygdala, to get associative control. You see, a reason we're there is addiction neuroscience can control the intensity of motivation with lots of different things now. But what controls the target of motivation? In daily life, you want different things at different moments. When you're hungry, you want something to eat. When you're thirsty, you don't want food, you want something to drink. And at other moments, you want something different. That's not food or water or something, it's something different. And in addiction, one thing in particular becomes wanted intensely more than most other things and in a relatively rigid, fixed, permanent fashion. And so what we're trying to do is get control of that, the focus and the narrowness, the breadth or the narrowness of the focus, and assign it, say, to the shock rod or to the cocaine or to the sugar. That's why we're in the amygdala. It's very good for helping to focus the wanting, but it's not doing it by itself. It's recruiting the dopamine system to power the wanting.
Okay, so the amygdala focusing and narrowing what to want.
Exactly.
So that I don't care about other stuff. I have focused, intense motivation for one thing.
Yes.
Wow, it's amazing. I think autistic people can have this kind of behavior sometimes. They will be focused on specifically one thing and they don't care about the rest.
We all have that focus, but I think you're right. In autism, it might become especially intense and narrowly focused at moments.
And where is the origin of valence, let's say? What decide what is good, I want it, and what I fear from, I don't want, is bad. Where it is originated, and also in the amygdala, or where? In how
well, I think in real life, many wants occur from pleasures, right? So liking, you find something, you like it, and now you're going to want it. So liking and wanting often do go together in real life, but the mechanisms are slightly different, and that gives rise to the possibility for the amygdala laser to create wanting for what hurts, and to create wanting in the absence of any kind of pleasure. It allows human addictions to develop too. But you raise an interesting question. What is it? Why is it a shock rod? Why can electric shock, act similarly to cocaine or sugar to become wanted rather than more feared? To be honest with you, when we started the shock rod experiment, I expected the amygdala laser to make the rats more afraid of the shock rod, so they do more defensive burying, kicking sand at it. And I was surprised and wrong, and found that instead it was making it wanted. The explanation I'd give is just a post hoc explanation, but this is what I think. I think the reason sugar and cocaine can, when you pair them with amygdala activation, become intensely wanted is because the sugar and cocaine, they themselves activate the limbic system a little bit every time you have it. And if you pair that activation with the amygdala activation, so they're both happening at the same moment, that makes that sugar intensely wanted, or that cocaine intensely wanted. Now, how can shock rod do the same thing? Well, the electric shock activates pain systems in the brain, but it also somewhat activates the mesolimbic system. Nucleus accumbens activation can happen in fear too. And we don't really understand how the structures flip between wanting and fear, but it seems that they do a little bit. They have a little bit of a shared mechanism, wanting and fear, a little bit of an overlap, not identical, but overlapping mechanisms. And I think that the overlap where they come together, that's what's allowing the shock rod to enter in with the amygdala laser to become wanted, just like the cocaine and sugar does. If it was a very terrible, terrible situation, I mean, the shock rod is mildly bad, but the rat can control it, and it can blame the shock rod because everything else is safe. But in a worse situation, like a Pavlovian fear conditioning situation where a sound comes out of the sky and the electric shock comes from the floor, and there's no way to avoid it and there's no way to escape it. In that situation, the amygdala stimulation might actually intensify fear. We have one study that suggested that. So I think mildly aversive things can paradoxically become wanted when they're paired with a amygdala stimulation, but a truly, truly nasty thing, that's not going to become wanted. And somewhere in the brain, you're right, is making this decision, but we don't know. We just don't know the mechanism that makes that valence switch decision. That's something we'd love to understand better.
Yeah. I will ask you last question if you have time, sir.
Yes, one last question I have time for.
Okay, thank you very much. We know that behavior is shaped by rewards and punishment. Organisms seek reward and avoid punishment. Even like bacteria, they will have their what's the name? Flagella or something, and will move toward glucose and avoid, I don't know, toxins. So, but humans, they have like consciousness, and they experience feelings and can communicate it. They experience feelings and thoughts and so on, imaginary imagery, and can communicate it with language. And I can tell you what I feel, for example. Now, what is the difference between, I don't know, when we say the rat feed, this is like we see behavior. He ran away, or he approached something, and feelings that we can communicate the experience of feelings, and are we really like what the difference between us, let's say, or rats? Maybe we are creatures that are totally governed by motivations and learned behavior driven by reward and punishment, and we have only like illusion of experience, feelings, and thoughts and imagery. Maybe it's just like a side effect of our developed brains, but maybe we are just governed like the rats by rewards and punishment and impulses. Yeah.
Well, I think that we are, in a sense, different from the rat in the sense that we have language and cognition and culture that is constantly influencing our interpretation of what's happening. And so our fear is probably not identical to a rat. Our fear is more complicated and we're aware of it in ways that the rat may not be quite aware. But I think it overlaps with the rat. I think what the rat has, we also have. And that's why we can study rats and learn something about ourselves. We have additional things happening in our minds and brains that aren't quite happening in the rat. And that changes the content of our experience. But it doesn't mean that the fear is essentially different. It just adds additional elaboration to our experience of the fearful situation. I think that's what I would say.
Okay, sir. Really, thank you very much. I really appreciate it. It was great honor to me for me.
Well, it was nice to talk with you. I enjoyed it, and good luck with your projects and continuing work and studies.
Thank you. Thank you very much. Thanks.
Bye bye now.
Bye bye.